You know, we're used to finding the circumference of a circle. So that's just the circle, the length going once around. If we take a look at this data, which we'll get to in a second, it's once around. That represents the circumference. But what if we just take a little piece of the perimeter, a little piece of the circumference? For example, this piece, or this piece, or this piece. Well, those are examples of what are called arcs. Arcs of circles, just little snippets, if you will, of a circle, of the boundary part. And actually, we can measure the arcs of circles, and in fact, measuring the arc of a circle is the same thing tantamount to finding the measure of the central angle, which basically means, essentially, that if you want to find the arc of this circle, this part of the circle, all you've got to do is figure out what angle that is. And whatever that angle is, that's going to be the measure of the arc. So the measure of an arc of a circle is in the units of degrees. Let's take a look at an example. So now here's some data. This circle that we're looking at actually represents a pie chart of some data taken looking at students walking around shopping in a mall. And the question is, what kind of shoes did the students wear? And there's sandals, sneakers, high heels, flip-flops, and boots. And the question is, I want us to find the measure of the arc generated by this piece of the circle where we see the students wearing flip-flops. So I could say this a little bit precisely if I wanted to. If I put A here as this point, maybe put a point right here, B, put a point right here, C. I'm asking for the measure of the arc A, B, C. I denote the arc with a little curve like that. So the answer is going to be an angle. And what angle is it? Well, I've got to find this measure of the central angle here. How do I do that? Well, I'm given the percentages, which means that this is 14% of the entire whole. Well, the entire whole, we know, is 360 degrees. So really, I want 14% of 360 degrees. So 14% of, that means times, so I have 0.14 times 360 degrees. And what does that equal? That works out to be about 50.4 degrees. And so the measure of this arc right here, generated by the flip-flop wearers, turns out to have a measure of 50.4 degrees. Notice again, the measurement of an arc is given in terms of degrees. And it just is exactly equal to the measure of the central angle.